all of today's lesson is about what we call solving triangles. You notice each triangle has 6 components, 6 things that make up the triangle. You get 3 angles, so big angle A, big letter B, angle B, and angle C. So we've got 3 angles. And what do we know about those 3 angles? If we add them together, we get 180 degrees. So big A plus big B plus big C was 180 degrees. And for this last section, mostly what we'll be dealing with will be in degree mode. Okay, 180 degrees is also pi. So we could measure them in radians, but again, since we're talking triangles, typically they're going to be in degrees. Then there are 3 lengths, 3 sides, and so there's the lengths of 3 sides, A, B, and C. So once we find all of those are all pretty much all the features we need to know about a triangle. Yeah, a triangle has an area and stuff, and if our class isn't going to that, but there's also a special formula if you know, like all 3 sides, you know, some angles, like there's something called Perron's formula that allows you to get the area of the triangle just from the sides. So you may see that in some of your calculus classes. So they kind of give you a few more formulas and stuff as you go on. But for this one, we just need to know those 6 pieces of information. To be able to find them, we have to be given 3, at least 3. If they give us more, that's even better, but we have to be given 3 pieces of information. So either 2 angles and a side, or 2 sides and an angle, or 3 sides will do. We'll see there's some things that will be helpful for us. And there's some things, again, depending on what information is given, we're gonna have 2 tools. So the law of sines will work in certain cases. The law of cosine works in the other cases where it doesn't work for sine. Okay. So first of all, you might have been noticing as we were working with triangles that the biggest angle in the triangle always also had the largest side. Right? And the smallest angle would correspond to the smallest side. And doesn't that make sense? Because if you're only open a little, there's only room for a little bit of length. If you're open big, you're going to need a big length to get there. Now, it's not a direct relationship. Knowing the angle, we don't necessarily directly know the side, but there is this relationship that was found out that if you take the sine of the angle and divide it by the length of the side, that ratio will be the same for each of those triangles, each of these pieces of data, right? So it doesn't really, this in itself is not necessarily something usable directly, except to use this ratio to find missing pieces. So what we're going to do, and again, like I told you, if 2 fractions are equal, the reciprocals are equal. So we get to decide which version of this we want to use. So, you know, like if we're solving for little a, we probably use the second one because less work. If we're solving for an angle, we'll probably use this first version, 1 and 2, simply because then the angles up there saves us a little bit of work. We could use either one, but I'm always about saving work, okay? And what we're going to see, what we need to be able to use the law of sines is we need an angle and the side opposite that angle. We could have other information, but we're at a minimum, we need a angle and side opposite. Is that right? Doesn't look right, but that angle. Okay. Do we need a right angle for this? No, they don't show right angle. We could have a right angle. We'll see that's okay. But if we have a right angle, a lot of times we've done something similar like this. But anyway, we don't need a right angle, but we can find them. So let's go ahead and look at it, because there is an option. There is a a circumstance where they give us certain information that there could potentially be two different triangles that satisfy that information. So sometimes we don't know exactly what triangle we have. We don't have an accurate picture, but we're going to see if the angle we're given is small enough, the other two angles could be different. Okay, so we'll look at one example here, go through the details and go. So what I always like to do is start by drawing a generalized triangle and labeling what we have. So again, you can go whatever order you want. Try to stick with what the thing that we were given. So this is big A, this would be little a, big C, this is little c, and this would be B. So we know big A is 33 degrees. I'll put that in there. We know big B is 65 degrees. And we know little a is 6.7 degrees, or inches, sorry, not degrees, inches. What do you think at this point would be the easiest thing to find? We need to find three things, right? We need to find big C, that's going to be in degrees. We need to find little c, and we need to find little b, right? Those are the three missing parts. Easiest. This one, we add the angles together, they all have to add 180. So that one doesn't even really involve any trig. We've got two angles here. We add them together, how much do we have? We've got 98. Did I get that right? And then how do we find the third angle? 180 minus 98. 7, that gives us 2. 9 from 17 is 82. You notice just arithmetic, no trig. Might as well take all the low line. Well, then how are we going to find C and B? So we could find C. We use this part of the, and either A or B, right? Well, actually, since we know little a and big A, this is going to be the main thing we're going to set up, right? 6.7 over the sine of 33 degrees. Now, this is another step, and neither one is right or wrong, but would it be best to try to solve for little b or little c? And why would one be maybe just a little bit better than the other? Let me ask you, if we tried to solve for little c first, what are we using? We would have to use an angle that we calculated, right? And if we use that angle that we calculated, this is my personal thing, I might have made a mistake when I calculated that angle. So if I can solve something that doesn't involve one of my calculations to this point, I'll do that first. Okay, so personally, what I'm going to do is I'm going to solve for B first, because they gave me the angle of 65. Okay, and so I've got one unknown here. They gave this to me. I'm just always careful about using calculations, using information that came from a calculation that I previously did. Because then if you got that one wrong, then you're going to get the next steps wrong and maybe everything else. So my suggestion, again, it's not that it's wrong, but go for this one here. We don't know little b, but we do know sine of the angle is 65. Okay, just a suggestion. So now that we're going to solve for b, what do? Algebra, right? So we want to get b by itself. simply multiply both sides by the sine of 65 degrees. Cancel with that. So it's just a calculation, multiplying this out, and we will get the measurement of little b. So let's go ahead and do that. Oh, I don't want the graphing calculator. We could use the graphic calculator, but let's go with the scientific calculator. So smaller. So sine of 65. And we are in degree mode, which is good. I think, right? That's degree. Good. Times 6.7 divided by sine of 33. And we're going to get that it's 11 point. Most of these, what it says is to put the, again, look at what Alex wants, but it wants it to the 10th, nearest 10th. That's the answer we got at 6.7 for A. So nearest 10th would be 11.1. And that's inches. So we put our units. So far, so good. Just like this ratio. So just have the formulas ready for you. You'll be able to use it. Now we do the same thing with C. Now in this calculation of C, we are sort of forced to use a calculation that we made on the angle, but sometimes that happens. But again, we could use B and sine of 65, but B was something I calculated. So again, it's best to go with as much information that was given to me as possible. So I will stick with using little a over sine of A because that was given to me. And again, it's just I am error prone. We should get, if everything else was done correctly, we would get the same answer. And actually, once you start doing this, you know, okay, maybe I'll calculate this separately. So I just calculate it once and then save it and I can use it because the same thing is going to happen with little c. It's now just going to be sine of 82. So you'll start to see this, the process is the same. Oh, I just need to multiply this side, right, by the sine of 82. So it's really the same calculation. Instead of sine of 65, it's going to be sine of 82 times these same numbers. That'll give us C. And so we go ahead and do that. In fact, let's see. I might even be able to come up here. I'm lazy, but there's reason. I'm not going to. And then when I hit enter, I get my answer. Did I get 82 right? Check my calculations. I looked good. Okay. So that's going to be 12.2, right? Rounded to one decimal place. We'll go with 12.2 inches. And again, a good way to check is verify sort of the size. C is the largest angle, 82 degrees. It's the largest side, right? So if you put them up here, that's always good to do. A is the smallest angle. It's also the smallest side. So things are fitting. Just going to do it. So that's the law of sine. It's the easy law of sine. Now, the thing is, you don't have to check to see if there's another solution for this. If there's two angles, we can't change those. So that's that trajectory of these two sides. You can't change it. We've got these two angles, both sides are going to be what they're going to be. There's one solution. The place we have to work on where there might be more than one solution is this next example. So this, what we did up there was angle side angle, or angle side. These two angles are fixed. You can't open them up anymore. These are fixed because wherever they meet, they're going to meet. Both sides are going to be the same. Now, we can use sine, law of sines for another type of triangle, which is called a side-side angle. These angles are not given to us. This is small enough, there might be a possibility the angles to be different. So when we go to solve this one, we're going to talk about how to look if there are two solutions. So the only time we need to worry about two solutions is the side-side angle. So when we set it up, so, oh yeah. Okay. And this is the example. With this given same sides and angle, one could be an obtuse with an acute, or it could be two acute angles. And both of those solutions could fit the information we were given. So if we don't have a scale drawing, we have to kind of say, here's two solutions. The other thing that could happen, we're not always guaranteed to have a solution, right? Because they give us some numbers. There's ways that if you don't have enough material, you actually can't make a triangle out of something. So there's potential that there could also be no solution. So those are the three things that can happen. One solution, two solutions, or no solutions. So just remember side-side angle. That's the one that's what's ambiguous. We've got to explore. There might not be a solution. There might be one, or there might be two solutions. But this is the one we're going to have to worry about. The other one, angle side, angle side, we don't have to worry about. Only one solution. We're actually going to look at several examples here. Find all unknown sides and lengths of the triangle given. So we're given, and we'll draw. Just go A. And it doesn't matter so much which way you put, where you put your angles and sides, just that whatever you put big A as your angle, you put little a as your side. Across from big angle B is going to be little b. We're told that A is 50 degrees. And then we need to find angle C and B, and plus the side of little c. Now, since those three things are not known, it's a possibility. Now, we would see that angle A should be, if we're doing this, right, angle A is 50, the side is 5.6. Angle B has to be bigger than 50 degrees, right, to make all this work. So we're kind of forced. We've got angle A, little a, and then we've got little b, and what the first thing that naturally we can go to find is here. And we've got to find that first, because then the only way we could find angle C is to add the two together, subtract from 180. So this one kind of forces us in a pattern that what we need to solve for next. But since we're solving for an angle, this time I'm going to use the one with the angle in the top, the numerator. So sine of A over little a is going to be sine of big B over B. And I substitute my values. Sine of big A over 5.6 equals sine of B over 7.4. And again, what you'll, oops, we know what A is, right? That's why we did that. Come back, sine of 50 degrees. Okay. So again, we're going to multiply both sides by 7.4. So that we'll have the sine of b. Now, that, notice this is not going to be our answer, but then we'll have to take the inverse sine. So we go ahead and multiply this out. Already set it up. Times sine of 50 degrees divided by 5.6. And that gives us 1.012. Now remember, we're going to have to take the inverse sine of this, so you want to use several decimal places. Does anyone see a problem yet? We'll go ahead, if you don't, we'll move forward. But think about how big could sine be? What's the biggest sine of any angle can be, thinking of your unit circle? 1. That number is bigger than 1. So when we go to take the inverse sine, we should get something that's undefined. That's what I'm. Hopefully we see that. Okay, actually I don't have to do it. Right, I'm taking the inverse sine of both sides. So that's going to give me that angle B is equal to whatever that is. But if I go for functions inverse sine, oops, it's clear. Inverse sine of 1.0122, it tells me it's undefined, right? And again, oh, why is it undefined? Because sine can't be larger than 1. Negative 1's the smallest side. So what does this tell us? If a part of the triangle is undefined, we must not have any solutions. Because if one part's undefined, how could we go from here, right? You can't figure out C if this is undefined. Can't get that, you can't get this, so we're stuck. This one has no solution. So it's just saying, basically, if there's this relationship between 50 degrees and 5.6, either B has to be bigger or smaller. With that size, we can't get an angle that's going to work. Okay, so this is the information we were given doesn't make a triangle. So that's kind of not so bad. When you've got undefined, you'll find that when it doesn't have a solution, you'll find in that first step that your calculations won't work. Here's another angle side-side. And if you guessed it, this will have either 1 or 2 solutions. So we're going to go through 3 examples, one with no solution, one with 1 solution, and then one with 2 solutions. So let's go ahead and label this. Here's A, that's 70 degrees. Little a is equal to 13 inches or something. Put big B there, little b 10.5, big C, little c. Okay. And again, just like we did before, we know angle A and little a. We'll go to try to find B first. So let's go ahead and set this up. The sine of 70 degrees with the angle on top, because that's easier to solve, over 13 is equal to the sine of big B over 10.5. And again, see the calculations really come out the same. Just need to calculate this and then take the inverse sine of it. So main 10.5 times the sine of 70 degrees divided by 13. Notice we get a number that is below 1, so this one could potentially have a solution. It's looking better. 0.75898. And then again, to solve for the angle, we just take the inverse sine. Inverse sine with sine cancels out. But we're going to look at, well, let's just go ahead and do this. We'll get one solution. And then we'll talk about whether we need to worry about an additional solution or not. What's also cool is since we've already got it entered, right, we could just directly calculate it this way. And we get that it's 49.4 degrees, right? We round that. That's definitely going to be one solution. Let's think about inverse sine. Do you remember with inverse sine, where do the solutions come from? Which quadrants are inverse sine coming from? The unit circle, it comes from either first quadrant or second quadrant. Right? Or sorry, first quadrant or fourth quadrant. Fourth quadrant if it was negative, first quadrant if it's positive. So we've got a positive value here. And so we've got this angle 49.4 degrees gives us this, but there's another angle that would have that same sine value, right? Where's that going to be? That would be in the second quadrant. There's also a similar angle where this is 49.4 degrees, and it will have the same value of sine, 0.75, so forth, right? So what is this angle? It's 180 minus 49.4. We subtract that. That's going to be 130.6. So, but would that work? Let's see. Well, if we put 130 in here, 70 plus 130 is how much? It's more than 180, right? You don't actually have to do it, but you can see it's going to be 200-ish. So in this case, we don't have to look for a second solution because it wouldn't work. The angle would be oversized, but we had to consider it. Okay. So this is a stage where if we get an answer here, we got to say, well, there could be this other angle. Let me see if there's enough material to work with. And what we found is the other angle would have to be 130. That's too big. It's not going to work. So we know that our B, solve it, is 49.4. So what do we know C has to be? Well, it has to be 70 plus 49.4. You get that, it's going to be 119.4. And then you need to subtract that from 180. That 120, that makes it 60.6. And they may want you to round it to the nearest angle, just whatever we want us to do. So we might list it as 61 and 49, whatever they want us to do, we do it. Okay. But I like to be as accurate as possible. So since these are the values we're getting, when we go to find C, I'm going to use 60.6. And again, while I could use the information for sine of B and such, I use the ones that they gave me. So I'm going to stick with the given information, which is angle A and little a. But again, this time I'm finding a length. So actually I'm going to shift. Oops, I guess I could leave that. I'll put the sine of 70 in the denominator. I'll put the 13 in the numerator so that I get little c in the numerator. And then the sine of big C, which is going to be 60.6, in the denominator. And it just makes solving it a little bit easier, right? Because I want to solve for C, I don't have to do, saves me one step. Let's go away. So C is going to be equal to this. Again, pull my calculator. There it. Sine 60.6. Again, always make sure you're in the right mode. 13 divided by sine of 70. You get 12.05, or we round that to 12.1. And again, we do a comparison of size of angle versus side, the length of the side, and it all seems to work. B is the smallest angle, it has the smallest side. A is the biggest angle, it has the biggest side. C is in the middle, and it all the ratios look like those. Okay. One more example, and then we'll get into law of cosines, and then we'll be finished with this course content. Now, what do you think is going to happen here? How many solutions are we going to get? We had 0 solutions, no solutions. We had 1 solution. So this one should be the 2 solution one. And again, it's a side-side angle, right? They're giving us 2 sides and an angle. So remember, this is the one we always have to check to see if there's 2 solutions. So that's little a's over here, little b's here, little c's here. And we know 44 degrees, A is 8, and B is 9.3. Okay. So the setup is pretty quick. We do the sine of angle A, which is 44 degrees, divided by its length. It's going to be equal to the sine of B, divided by its length. And again, just a calculation, 9.3, 9.3. So we'll put all of that into our calculator. There, 9.3 sine of 44. Close that, divided by 8. And we get 0.80754. 80754, right? And that's going to be equal to the sine of B. Now, remembering from the last one, since it's positive, that solution is in the first quadrant. And so we'll get that angle. There's potentially one over here that would have the same sine value, right? That's 180 minus this angle. So we'll do the check when we get there. Okay. So again, we want to take the inverse sine of this number. So we can do that here. That. So that's 53.9 degrees. Rounded is this. Inverse sine. And again, these examples I took out of the notes that are above it in Canvas. So if you want to see a typed up version of this, you'll see them with more writing. That's in there too. Okay. So if this side is 53.9, so this is one solution we got. Let's go ahead and get what C would be. So we take 44 plus 53.9 4 and 3 is 7. That's 97. So then we take 180 minus 97.9. And that's going to be 1. 7 and 9 is 2. And the 9 from 17 is 82. So there's one solution within, then we can find C. But before we go much further, let's see if there's potentially a second solution. So if this is 53.9, what would the second angle over here be? It would be 180 minus 53.9. So that'll be 1/10. 3 from 9 is 6. And 5 from 17 is 12. So 126.1. Could we make a triangle with a 44 degrees and 126 degrees? Six and 4 is 10. Carry the 1. That's 6. That's 7. Oh yeah, there's 10 degrees left, right? Take 180 minus that. That's going to actually 9.9 degrees. So we could also have a second triangle where angle C is 9.9 and angle B is 126.1. I'll draw that triangle as my alternate reality. Actually, since I know what it is, let's see if we can kind of draw it. So 126 degrees is B. That's going to be an obtuse angle. Right? It's going to be greater than 90. There's an angle B. Angle A is still 44 degrees. I'm not going to say that this is to scale, but and then angle C is going to be 9.9. Angle B is 126.1. So notice the lengths of the sides will be different, right? So once we got this one, we're going to get really two different solutions. So we'll go through with it. Oh, wait. Sorry, B is given to us. So B does not change. But C will obviously be a different measure. C is down here. This is A. It's 8. Okay, so we'll find this one. We found those degrees. We just need to find those C. Okay. So go back to blue, finding this measurement here. And we stick with, since now we know the angle and we're looking for the side, let's go ahead and flip this. We'll do, this is a sine of A, right? So sine of 44 degrees with the little a side here, 8. Little c over the sine of 82.1. Okay, so to find C, by both sides by the sine of 82.1. And we'll get that one directly. So for this one, we're going to get C is equal to 11.4. So the red is what we would put in as one solution, these angles. Highlight down here. For this second solution, we would do the ones that I've got circled in blue. And you could do this check. We'll check this to make sure it works out, but let's go ahead and find C. We'll do basically the same thing we did here. That side A over the sine of 44 is equal to little c, but this time over the sine of 9.9, right? By both sides by this case. The nice thing is in our calculator, we can just change that up here. 9.9, and we get that C is now 1.98, rounding to one decimal place, it's going to be 2. So that'll all round up to 2. There. What I'm going to do is notice B is now a different angle here. So is it still true that the ratio works, that 8 over sine of 44, is that still equal to 9.3 over the sine of 126.1? Now, if you're thinking of this, it should be, right? Because the sine of 126 is actually going to be the same as the sine of 53.9. That's how we got it. So that value is going to be the same. So this should all work, but it's worth at least checking out. So what I would do is, let's get rid of this. Just make sure that those ratios, so 8 divided by sine of 44 is 11.5. And so let's see if 9.3 divided by the sine of 126.1. Now this is a rounded value. We might get a little bit of difference. We do, probably rounding errors, but they're close enough, right? At least the one that's place. So that's kind of always good. When you find a second solution, make sure that all the ratios work. Okay. But this is what you want. You probably want to put this in your notes. The only time you need to check for a second solution is with the case of side-side angle. When they give you two sides and an angle, that's when we're going to have to see if there's two solutions. Okay. Notice we went through 3. If there's 2 solutions, 1 solution, or no solution. So that's the middle energy left. Pushing through to the last bit. So now, what is the law of cosines? Going to take a little break. Do that too. Law of cosines. What I want you to see here, what does this look like? A squared. Usually we would see it this one, right? A squared plus B squared equals C squared. If that was all you saw, what would you call that? Pythagorean theorem, right? But what's this minus 2AB cosine of C? Well, let's think of what if C was a 90-degree angle? What is the cosine of 90 degrees? 0, right? So if this was a 90-degree, this part becomes 0, and there's your Pythagorean theorem. Okay, so this is just, it's the Pythagorean theorem for any triangle that's not a right angle, a right triangle. Okay, so this is sort of, I don't know, call it an adjusting factor, but it allows us to use it. So with these oblique triangles, which are non-right triangles, okay? So they will work. We can use this when we have a side angle side. And again, look at this one with a side angle side, this one here. You can't use the law of sines because you don't have an angle in the side opposite, right? We can't use it. That's why we can't use the law of sines. Side, 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 we don't have any angles, so we can't use the law of sine because we need that angle. But notice in all these formulas, you have all three sides and you have one angle. So we'll be able to solve for the angle. So cosine is our kind of our utility law, where we do the ones that, you know, if we don't have anything else, we use it instead of law of sines. If we can use a law of sines, it's a much easier, right? It's just those ratios. This has got a lot more stuff to plug in. At some point, right, we may need to take a square root. It's going to get messy in the calculations, but it's the tool we have for these two types of triangles. It's the only one that will work. Okay, so we've got a couple of, actually, I think one example, and then one where we're going to work on setting up the triangle, which is the major part of it, getting the way they give us the angles. To find all unknown angles at sides, we're given one angle, two sides. And again, it's always good to draw it out. There's A, put that there, there's 48 degrees. Little b, so if this is big angle B, little b's over here. That's given, this is big C, little c is over here. And notice we don't know A, we can't use the law of sine here, so we're forced into the law of cosines. Now, we have a choice. I'll label these 1, 2, 3. We have this set up. If we know B, C, and angle A, which we do, we can solve for A. And that would be my suggestion, because then there's a lot less algebra to do, right? It's going to be mostly calculation, and this will be our answer. All we have to do is take the square root of this side, and then instead of A squared, we've got A. Okay. So we can say that A, we'll leave it as A squared first. And again, sometimes I like to just write these out a couple times because it helps me get comfortable with it. And then I can fill in the information as I go. So B, they gave us was 19. C, they gave us was 16. Minus 2. B is 19. C is 16. And then we get the cosine of 48 degrees. It's not an exponent, it's that. And since we're solving for A, let's go ahead and just take the square root. So we'll get our answer all in one step. Okay, so it's more complicated to answer, but in another way, the solution is pretty straightforward. Let's clear this out. We're going to put all this in, square root 19 squared, arrow over. Let's see, what do we have? Let's see if I'm still there, plus 16. Got to make sure I'm still inside the square root. 16 squared minus 2 times 19 times 16 times the cosine 48 degrees. And again, make sure you're in degrees. And after doing all of that, we get our answer 14.5 rounded to 1 decimal place. Now, what's the advantage of solving for that side first? What could we do now? Switch to the law of sines, which is a little easier. You could continue using the law of cosine to find angle C and B, and you could. Again, to me, it's more complicated. I'm going, even though this is a calculated angle, it's going to be probably more accurate to switch over to 14.5 over the sine of A. Oops, no, I want to have it the other way around, because I'm going to solve for the angles, right? So sine 48 degrees over 14.5. And then it doesn't matter which one you want to do. Let's go with B, sine of big B over 19. Okay, multiply both sides by 19. So, and then take the inverse sine, right? So, okay, if I leave you guys to do that one, I've done enough of these, then I could do the same thing to find, well, then once I've got angle B, 48 degrees plus angle B, and then subtract that from 180, that'll give you C. Okay, so just like we did several examples with those. But law of cosines. So usually you only need to use the law of cosines once, and then you can start using the law of sines. Here's a side, side, side. And again, once we have one of these solved, and this one we will go through. So we'll do little a, little b, little c, a, b, and c. Okay. Again, you could use any one of them. Let's go ahead and solve for the angle A. If we're going to solve for angle A, that's going to be a squared equals b squared plus c squared minus 2ac cosine of big A, right? Just make sure. Yeah. Whoops, not AC. BC. There we go. So plug in our values. 1.25 squared equals 2.73 squared plus 2.51 squared minus 2.73, 2.51 cosine of A. And so what we need to do, as you see, it's very complicated. We need to isolate cosine of A. So we subtract this and this from both sides. So we're going to get 1.25 squared minus 2.73 squared minus 2.51 squared, negative 2, 2.73, 2.51 cosine of A. And so then we divide both sides by the numbers here. And that's going to give us the cosine of A. And then what do we do? We're going to need to take the inverse cosine of this, right? So another thing you might do is actually come up with these. Notice if you ever have a side, 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 this is where you're going to go. You can make that up as a little formula and just plug it directly into that. Then it's a couple of steps of algebra. But again, you just see that the complication with the law of cosine is you've got a lot of stuff in here. So I like to go ahead and let's do the inverse cosine. So after we put everything in, we get our answer directly, and we're not having to retype in answers with decimal places and all that kind of stuff. So we need to put all of that in there. Let's go back to main. Let me do this. I'm going to, since we have a fraction, I'm going to do the A over B. It just helps me to put everything in there a little nicer. Make sure you get your subtraction parts. Five, 1 squared, and then in the denominator, we have -2 times 2.73 times 2.51. That's it. Got everything entered. Whoops, not 0. So that's 27.2 degrees. So that was angle A. And now, since the sides are fixed, all we have to do is find B or C. We can use the law of sines, get that, and then we can find the angle that we didn't find by adding together, subtracting. Just an example of how we directly use law of cosines for that one step and side by side. We need to use law of cosines. We only need to use it once. And then we'll switch over to the law of sines because it's easier. Yes, you could continue to use the law of cosines, but